Testing. Good morning, everybody. That was not good enough. Let's try again. Good morning, everyone. Welcome to one of your first reInvent sessions. Who over here is at reInvent for the very first time? Oh my goodness. Oh my God. This is incredible. We're on this journey together. Welcome. I'm really excited to kick this off with you. Today you're here to not just learn about the cloud, but how cloud is making a difference in the lives of people and community. How does cloud generate positive social impact? I am Anya Niaz, and I am the Global Lead for Education Equity at AWS. In the session today, we're going to look at the role of cloud in generating social impact, as I mentioned, and then we're going to dive really deep into topics like education equity. What does that mean, really? And how does AWS play a role in contributing to that? We'll then dive even deeper to understand how cloud technology unlocks agency, leveraging AI. I'm going to keep pausing a little bit so I remember all my lines really well. I'm especially thrilled today to introduce you to two highly influential voices in education. We have with us today the Chief Product Officer of Code.org, Reimagine, and the Director of Scratch Lab, Eric Rosenbaum. Please join me in welcoming them onto stage. Woo! Okay, great. Thank you, Kareem. Thank you, Eric. We can grab a seat if you'd like. Come on. All right, so before we kick off the session, I'm sure the audience would love to learn a little bit more about you. So why don't we take a couple of minutes? You guys get to know these guys. Kareem, please kick us off.
Yeah, hi everyone. Welcome to reInvent, first session. Nice morning start. It was amazing to see so many new folks at reInvent. I was talking to someone earlier today. The last time I came to reInvent, there was about 12,000 participants. So now it's 60,000 participants. So you're definitely part of a movement in terms of what we do with the technology that we build. So I'm Reimagine. I'm the Chief Product Officer at Code.org. Code.org has been doing what it does for the last 11 years. I've been there for about 2.5 years, and I'm excited to share with you some of the really interesting things we're doing with AI in the classroom using AWS technology.
Cool. And I'm Eric Rosenbaum. First time at reInvent. Very excited to be here. I work at the Scratch Foundation. People familiar with Scratch? No Scratch? Oh, I see some hands. And some people are not, so I'll give you an intro. And what I do there is our innovation work. Scratch Lab is where we invent new creative possibilities for the future for creative coding for kids.
Amazing. Thank you so much. Eric, Kareem, join me again, guys. Have a seat.
Have a seat? Okay.
Yep. All right, so before I hand back over to Kareem and Eric so you can hear more about them, I'm going to set the context for you. Let's talk a little bit about how cloud is generating social impact. We do this across multiple sectors, including health, disaster response, environment, and education. For an example, how many of you are familiar with Hurricane Helen? So think about it this way. Cloud technology was able to help leverage high-image aerial satellite imagery, which helped identify where people were, and that information informed humanitarian organizations and first aid responders to send help where it was needed most in a timely way. In health, we support organizations such as Jacaranda Health. Jacaranda Health is an organization based in Kenya, and they help women who are pregnant or who are trying to be pregnant get the support they need. Questions like, what's the right food I should eat? I'm experiencing a certain type of pain. What should I avoid? What behaviors should I be adopting? All those questions they can ask through a simple information system and get responses, all of this being built and scaled on cloud technology. In education, there are so many different ways in which we get involved, and I want to today focus on the term education equity. What does education equity mean? Education equity is every single learner, irrespective of background any characteristic is able to access education and opportunity around the world. Education equity is important because it means every child with the right skills, behaviors, knowledge, and belief is able to participate and thrive in an increasingly tech-driven world. How many of you can relate to that, like needing to acquire skills so you can be part of the digital society? How many of us have young kids under the age of 10? How many of you are wondering, what does AI mean for my kids' education? I don't have kids yet, but I'm wondering. Great, so we're gonna dive deep into some of these questions and learn from some of the best minds in how AI is playing not just a role of improving education, but is diving really deep into accelerating agency. Oop, the screen's not showing. Oh, thank you. Oops. Thank you. Whilst that's happening, let me just take you through a little journey around what all AWS offers around education. How many of you are familiar with Skill Builder? That makes me happy, at least half of you. Skill Builder allows you to access both free tier and paid education, skills and knowledge around all the key topics in computer science, everything from AI, solutions architect, et cetera, et cetera. We also have the AWS AI ML Scholarship. How many of you have heard of that? Great, I saw a couple of hands. The AWS AI ML Scholarship allows students to be able to, for free, get trained in both artificial intelligence and machine learning. We also have Amazon Future Engineer. How many of you are familiar with that? Thank you. Couple more hands up, excellent. Amazon Future Engineer is our key K-12 computer science offering. It is for students K-12 as well as educators. So you basically access a host of materials that can seamlessly integrate into curriculums in school, after school, to help K-12 learners become as equipped as they can be with computer science latest. Great, one moment. All right, so and not just that. We don't stop there. Going back to what I just asked you both, all of you, not you both yet, AI is bringing up lots of important critical questions that are mostly centering around the key critical education stakeholders: teachers, parents, caregivers, and students. For an example, teachers are wondering, how do we use AI that does not replace us? How do we use AI that helps improve the way we deliver learning? And how do we use AI that is safe for our children's education journeys? At the same time, students are wondering, how do I use AI to make my learning easier? How do I use AI to make my learning more fun? Will I be allowed to use AI? As some of you might have noticed in the news, there's blockages coming up around AI as the world and schools are grappling with coming up with the right AI policies. We're going to see some of these questions be addressed by both Kareem and Eric around use cases from code and Scratch. Great, all right, well, without further ado, I'm gonna hand over to Kareem, who's gonna take us through the AI Teaching Assistant, which is helping save hundreds of educator hours. Over to you.
Thank you. Yeah, so fixing AV, something AI can't do. It takes a human to do that, so remember that. Yeah, it's awesome to see you all. Thanks again for coming to the session this morning. I'm going to talk a little bit about what we do at code.org. And first, I'll start with just telling you a little bit about code.org. So let's play a video for you.
Big problems. But I'm little, what can I do?
Even when problems seem big, we can tackle them one step at a time.
Our generation can help make a more prosperous, equitable, and sustainable world.
I'm learning to code.
I'm designing apps that solve local problems.
I'm programming robots.
I'm learning computer science to make change happen.
Because with technology, we could build robots to clean the world's oceans.
We can program drones to detect forest fires quickly.
We can empower young women with digital skills and tools.
We can program mobile apps to streamline farming in poor rural areas.
We can use gene sequencing to diagnose diseases.
And create personalized medicine to cure them.
I'm little, but don't look at my size.
Look at my potential.
I can make change happen.
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 So it's interesting. I've watched that video like, I don't know, 50 times, and it's still as powerful today as it was the first time I watched that video, because it gets to the heart of what we're going to talk about today, which is empowering our students, empowering our classrooms, empowering our teachers, giving them the agency in those contexts to use this new technology. And so that's something that's a cornerstone of what we do at code.org. So we believe if you teach students durable computational thinking skills, if you teach students foundational CS and AI knowledge, if you can inspire them to like tap into that natural creativity that students have to want to build things, you can empower them to literally change the world, and that's what we're about. So our mission is to bring the opportunity for students across the globe to take computer science education. We do this by advocating for policy change at the state and national government level across the globe. Here in the United States, 11 states have now passed a graduation requirement where students have to take 1 semester of computer science to graduate. We think it should be all 50 states and all, what are we at, 200 countries? So that's how important we think it is. It should be just like biology, math, science, things that students take in their core curriculum, and that should include AI now. The second way we do this work is by changing societal perceptions about who belongs in the computer science classroom. If you look at the computer science classroom across the globe, it is not representative of the student population. Girls are underrepresented, and students from a variety of racial backgrounds are not in those classrooms and have to be in those classrooms. So that's an important component of the work we do. We also build free, high-quality curriculum for students so that there is not an issue of access, and high-quality professional development and training for teachers. If you don't have teachers, you're not going to get the students with the skills that we want. And then finally, we support school districts across the globe getting the curriculum into the classroom and landing it well, i.e. having students performing in those classrooms as we'd like to, developing those skills, assessing well so they can go on to do the things that we all would like them to do. So code.org has been around for now almost 12 years, actually. I usually say 10 years, but I'm undervaluing by a year and a half there. And so in that 12 years, we've reached 92 million students with our curriculum, just over 3 million teachers. Our curriculum has found its way into 180 plus countries, and we translate into over 60 languages. So pretty wide reach. On an annual basis, we have about 10 million students working with our curriculum. And we hope to grow that. The Hour of Code, which is maybe something that folks have heard about. Just give me a quick hand raise if you've heard of the Hour of Code. Okay, a few people. So Code.org founded the Hour of Code and facilitates this campaign every year. The goal of the Hour of Code is to essentially, with 1 hour of coding, inspire students to want to learn more about computer science, coding, and AI. So that's what we're trying to do with the Hour of Code. If we do that, we get more students into those classrooms. Hopefully we generate momentum with teachers and districts and administrators and governments, and we get more computer science taught to our students. Over the course of 12 years, we've taken students through 1.8 billion hours of code, and that's continuing to grow every year. So AWS, we are primarily an AWS shop. So all our products that work at volume, at scale, high availability are running on these services. So just a quick tour. Sure, I'm sure most of these are services you're all aware of and use. So for our core application, we run on EC2, S3 as you'd expect, RDS, and we sit in a VPC. We do our data analytics pipeline through Redshift. And our newest AI products and curriculum, which I'm going to talk about one product today, are built on SageMaker, Bedrock, and Comprehend. So I'm going to talk to you about the AI Teaching Assistant. This is one of our newest AI products. And I'm going to start with why. Like, why build something like this to begin with? Well, the why starts with the fact that we asked our teachers. Over the last few years, we do an NPS survey twice a year, and we ask our teachers, tell us how we're doing, tell us how our curriculum is working, how our tools are working for you, and we ask them to give us feedback on the areas that we can improve. And you'll see here, it's that second row, assessing student learning, grading, and giving feedback. Highest piece of feedback. So over a third of teachers that responded to the survey and told us what they wanted us to improve said, give us tools for assessing feedback. Now you see this goes back here to fall of 2022. I didn't have enough space in the slide to show you earlier, but the pattern has been consistent. And prior to actually the generative AI wave that we've seen, it was hard. We're a small tech team. We're a nonprofit. Building a machine learning model to do assessment of student projects at a high level of quality is not an easy thing to do with the kind of resources and budget we have. But we thought that this would be a really good thing for us to do, and at the beginning of 2023, when we really started to play with generative AI, we realized that this would be a great technology to help us solve the problem. And so that's what we did. We built an AI teaching assistant, and the first feature that we included in that teaching assistant was a feature to assess student projects. So what we do is we take the LLM, we feed it students' code, we feed it a rubric, and then the LLM gives back, with obviously grounding and nice prompting and a number of other techniques, gives us back an answer to the question, how did the student's project do against that rubric? It gives the teacher the evidence of the actual the student doing the thing that they were supposed to do, and then the teacher has the ability to adjust the feedback and then ultimately submit that back to the student for follow-up. So the teacher is feeling much more in control of the situation with a bit of support, and that's what we're after. Let me play the video, show you a little demo here how it works.
In this video, we'll give you a quick tour of Code.org's new AI teaching assistant, which can currently be found in the CS Discovery's Unit 3 Interactive Animations and Games. Let's take a look at how it works. When you go into a student's project, you'll find the floating action button here in the bottom left-hand corner. Clicking on this opens up the TA. We can see the rubric criteria one row at a time, and we can toggle through each row here. Let's go ahead and run AI assessment for this student. Once the analysis is complete, you'll get a notice at the top of the window, and then we can start going through each row to see the scores that the AI suggests. For criteria that is capable of AI assessment, you'll see a suggested score. You can see here that the AI suggests a score of either convincing or extensive. You will also find the evidence AI found to support the suggested score. The lines are listed here, and it's highlighted in the code. If you want to take a better look at the code, we can move this window so that we can see those lines of code that the AI is suggesting as evidence. After we select a score for this row, it's a good idea to indicate how the AI did with this thumbs up or thumbs down rating. And then you do have the option to give the student feedback on this particular row if you would like. After you have scored all the rows, you can see a summary of all the scores at the end of the list. Submit those scores to the student with a click of this button here, and you're ready to start scoring the next student's project.
So that's the AI teaching assistant. One of the things I should have mentioned before showing that video, one of the insights when we spoke with teachers a bit more about what would they want in terms of feedback and assessment, and why, what was the problem statement beyond just maybe the obvious, it takes time. A lot of teachers are new to computer science that are teaching middle and high school. So there's probably a lot of people in this audience that would be second hat at looking at a student's body of code and assessing it quickly. They might assess it, but they don't have the confidence in actually saying, I got it right. So they're going to spend more time to ensure that they get it right. And so we found a lot of teachers felt like a lack of confidence in their own assessment skills, it's an important thing, right? You want to, again, back to the agency point, teachers need agency too. They need to feel that they're supported in the work that they're doing. And so that's one of the things that we learned after we started talking to teachers with the tool in hand. So what we did is we piloted the teaching assistant in the spring and through the summer with a few hundred teachers, and then we launched it in the fall of this school year. We're now in the thousands, and we hope to get to tens of thousands over the next couple of years with this capability overall. But what we learned as we went through this piloting process was, number one, it was saving them time. And time is so precious in the classroom. We want our teachers working with students directly on the things that are uniquely human. And here's an area where an AI tool can help a teacher be more efficient, more effective, and therefore spend more quality time with students in the way they need. So that was one learning. The other thing was, as I mentioned, confidence. But a third that I thought was interesting, because a lot of folks, we talk about AI and bias, right? We know that these models can have some challenges based on training data. here was a human saying, this tool is helping me actually make sure I'm not biased, which we thought was a really fascinating outcome. And we did testing. We actually benchmarked our teachers at how they assessed projects and compared that to the AI model and found that in a number of cases, the model was actually assessing better than the human. And that's okay. It's there as a tool to help them. And so we felt pretty good about where we're at today with the tool. We intend to scale it up. Let me tell you a bit about the technology behind this real quickly here. So we use Bedrock and we use Claude. As I said, we're an AWS shop, so we absolutely wanted to look at Bedrock because it just fits in with all the other tools that we use. But as we looked at Bedrock closer, we found a couple things. One, we felt it was highly configurable and very easy to debug. And the techniques that we were using in terms of our model solution, it was very easy to iterate with the platform. So we do some RAG approaches, we do some metadata filtering, some response processing, and this pipeline was what Bedrock really helped us with. So the developer velocity, again, small shop, was very positive. We also then benchmarked 4 models, including Claude, against our particular use case and set some quality baselines in place, and Claude did the best on our tests. So we were excited about that. We want a high quality model that's assessing well, again, back to the point of it has to do well for the teacher to feel that agency. And then the last point is Claude had some features we really liked. Artifacts is one of the features that we plan on using. So there were a number of things that led us to this solution, and it's worked out really well. I'm going to give you a quick peek into what we're doing next. So the next feature that we're going to build before I play the video is a feature to help teachers with differentiation. Just raise your hand if you know what I mean by differentiation. Okay, I'll explain it real quickly. So students are at very different places when in their classroom, right? We're all snowflakes. We're at different places in our learning journey. And when you're a teacher and you've got 30 students in the classroom, you want to be able to teach to every student. But sometimes you can't always do that. You teach a lesson that's for every student, not individualized, right? Differentiation essentially allows a teacher to see each student as they are, understand where they're at skills, where they're excelling, where they're struggling, and if you will, customize their teaching and their lesson planning for the student. And so that's the next area. If you were seeing on that NPS slide with the data that I showed earlier, the second most requested help was with differentiation. So here again, we thought, okay, let's see if AI can help us with that. So let me show you a quick demo of our differentiation feature. This is not even released yet. It's still, it's probably past prototype, and we're starting to test it now.
Code.org is excited to tackle one of education's toughest challenges, differentiation in computer science classrooms, in our AI teaching assistant. Code.org has long supported teachers with custom lesson plans, resources, and professional learning materials to help with differentiation. Our new AI teaching assistant takes this support to the next level. This innovative tool combines all these resources with classroom context to explain concepts in relevant ways and create tailored extension activities. Let's see it in action. In this level, students learn about variables, one of the most important building blocks of coding. AI Teaching Assistant helps a teacher make adjustments in the moment to make sure every student understands and retains this important concept. Here we ask AI Teaching Assistant to explain variables to a student who has been struggling but is really motivated by an upcoming readathon. It responds by recommending we set variables for the student to update as they read more pages. In this example, the AI Teaching Assistant worked as a collaborative partner for teachers. It works to understand the original lesson and its place in the curriculum progression. Then it incorporates the teacher's unique insights into student motivations. Finally, using a best-in-class generative AI model, it returns a brainstorm of custom activities drawing from resources like Code.org's approach to differentiation.
There you go. Thank you very much. Back to you, Anya.
Thank you, Kareem. That was inspiring because we're not just hearing about how educators' time is saved. So they're spending, up to less than 50% of that time grading these coding projects, but also that the decision on the grading stays with the teachers. The AI tool is providing them with qualitative nudges and evidence-based feedback that they decide to do something with. So just going back to the question that I'd raised earlier, educators asking, will AI replace us? This example shows us AI aids them, it supports them, it frees up time, and I've been an educator myself. to do what matters most, to focus on the differentiation that Kareem was mentioning, to maybe tweak those lesson plans, to maybe think about doing less of that admin and more of the time that I can spend interacting with students, thinking about their aspirations, understanding what the parents might be seeking. So thank you again, Kareem. We're now going to turn our focus to students and student agency, and we're going to welcome Eric to talk to us about how AI is unlocking learner agency.
Thanks. So I work at the Scratch Foundation, as I mentioned, and my work is exploring the future possibilities for how we can give kids creative coding tools that help them learn and grow. And we deliver those creative coding experiences to kids all around the world at a scale where we really need AWS to help make that possible. So what is Scratch? We are, in a nutshell, the world's largest online creative coding community for kids. Kids use Scratch to make their own games and animations and an incredible variety of other interactive projects. And then they share them with a global audience of other kids around the world in our online community where they can comment and collaborate and befriend each other in a context that's safe and friendly. Kids make an incredible variety of stuff. You could see on the slide just a few recently featured projects. There's one about a little black cat, one about infinite monkeys. What do the infinite monkeys do? You'll have to click and find out. There's, what else? There was a dress-up game in there somewhere. I think it's about a robot. Interactive pets. The creativity of kids on our platform is incredible, and you can go and see new things every day. There's about 500,000 new projects posted by kids every day. Scratch is about a lot more than just dress-up games for robots, and it's about coding, but really it's about self-expression. We're putting coding as a tool into the hands of kids to help them change their sense of what they can do and make, and ultimately who they can become. We believe that Scratch has this transformative power on kids' lives. Just in the past couple of weeks, I've had a couple conversations with young software engineers who mentioned to me that, oh yeah, I got my start on Scratch. One of them, they found, going back, that there are a couple dozen creative projects that they made from 2008 were still available on their website. So they could go, I actually clicked through and found a dragon that burped that this person made. And I thought, wow, that's a wonderful beginning. And as we scale up, these people who say this was a really critical part of my sense of who I am as a person who can use technology to change the world, that population of people who've experienced the transformative power of Scratch is only going to grow. How do we do it? The way in which we put that agency into kids' hands is to follow what we call the creative learning philosophy. So this was developed by the folks who created Scratch at MIT Media Lab starting in the early 2000s. The project was led by Professor Mitch Resnick, my PhD advisor also. And it's based on the idea of creative learning, which we illustrate with these 4 Ps. So kids make projects. They create interactive games and animations that are about their passions, things that they care most deeply about. You can use Scratch to make a project about anything you're interested in. With peers, they collaborate and share in our online community. One of the features of Scratch is remixing. If Tom makes a project, I can click remix and make my own version of his and then share that. And it's all based in this spirit of play, of creating through experimentation, through tinkering, through taking risks to try new things in an environment that's safe. A little bit about our reach. Over time, we've had over 100 million users who've created over 1 billion creative projects. We serve a wide range of kids in every country in the world, and it's free to everyone all the time. And then zooming in a little bit, we've seen some exciting growth. You could see at the beginning of the graph, there we are in 2007 at the day we first launched. We started to ramp up once we changed platforms to make it easier to access Scratch on the web. At the time that we developed Scratch 3, the current version, was also just before the pandemic hit. And you see a spike of activity there because Scratch was this safe, online, creative community that kids felt comfortable in. And we think when they were stuck at home, they came to us. So that created a huge wave of creative activity on our site. We're up over 2 million projects shared per month and growing. So under the hood, there's a lot of AWS services, as you can imagine, to do things like manage identity and auth, the storage of all these multimedia projects that are full of images and sounds and code, things like searching and routing. But I'm going to talk about a couple of the services that are more user-facing that we've had deployed for a little while. Amazon Poly and Amazon Translate, which we actually make into coding blocks. So Scratch, as a programming language, if you're not familiar, is made up of graphical blocks that you snap together on the screen to create your code. And one of those blocks is called Speak. And it uses Amazon Poly, the text-to-speech service that Amazon provides, to power it. And let's see what this looks like.
Hello.
Here we go.
Here we go.
Hey, look, I'm flying.
So there you could see just an example of clicking on that speak block to try it, which is how we encourage learning through tinkering, and then building up a simple program that makes an animation, combines that with the speech balloon and a little bit of movement with the speak block to make the character come to life. So that's just one minimal example. One really amazing thing that happens when you design creative technologies for children is that, and I see this actually as a goal when I'm designing creative tools, is that kids will use things in a way that you never expected or imagined. And one of the wonderful things that we see with the speak block is that kids use this text-to-speech capability to create their own DIY assistive technology. In other words, projects that can speak for them. This project, an alternative and augmentative communication device created by a kid, was made by a kid who explained that they are neurodivergent and they occasionally have these nonverbal episodes, ones in which they cannot or will not speak aloud, but they need to speak. And so they built this tool where they can type in something at the bottom, like you can see, I need help. And then to customize it for themselves, they used Scratch coding to make different modes. So it can speak for them in English or French. And that's one example, but there are actually hundreds of these on our site, just this specific idea of using the speak blocks for DIY assistive tech. The speak blocks get used a lot. I went to look it up. We've had almost 1 billion Poly requests in the past year. It's a really popular feature and really excited about all the different ways kids are using it. Oh, there we go. I clicked the button. I didn't know it was going to happen. Another AWS service that we use is language translation in text. And for that, we have the translate block. And so you can see an example here. That say block makes the speech balloon appear for the bat. And I wanted the bat to say, let's invent, but in Portuguese. And so I can use that block to translate text into any language that I want. And this is incredibly useful, as you can imagine, in combination with other blocks, so that, for instance, if I make my animated story about my journey to Vegas, and I want someone who's in Japan to be able to read the text, I can use that block to translate everything in my project, or say it's instructions for a game, or any other kind of project that I make. And of course, you can combine it with that speak block to have it speak in other languages as well. And that's the incredible combinatorial power of coding. So kids use this block in an incredible variety of ways. So I want to talk a little bit now, of course, about our experiments with AI. We're at an earlier stage with respect to delivering these experiences to children. So these are just, I want to emphasize, some early prototypes, some ideas that we're excited about and just beginning to develop. And the focus for us, it's really inspiring to see the code.org work delivering teacher tools. The focus for us is on putting the power of AI into the hands of kids, which raises some different kinds of challenges. And so these solutions that I'm going to show you are speculative. We have a lot of ideas. These are a few of them. And at the heart of the work is centering the creativity and agency of kids. So here's one prototype. What if you could use AI to explain code? You might load up another person's project, because all those millions of projects on Scratch are open source, and wonder how it works. And so you could have the AI explain the code. In this example, you could see a little Pong game. That green paddle has code that makes it move back and forth. It says, when the green flag is clicked to start the game, forever set X to mouse X. But like, what does that do? And so if you had a little explainer with AI, it might say something like, the selected sprite continuously sets its X position to match the mouse's X position, allowing the player to control the paddle's horizontal movement. Is that helpful? I don't know. What else would you want it to do? We don't know. It's an early stage prototype, but is an interesting direction with respect to helping kids along their learning journey with Scratch as they learn to code. Another idea is an AI coding assistant. You're probably familiar with the tools, the co-pilots out there that help you as you code as a software developer. What if kids had that kind of power? How might we want it to work? And so one idea that we've explored is having it code for you. This is not necessarily the direction we're going to take, but it's fun to play with. And the key idea is that you have a kind of conversational back and forth between asking it to provide code and playing around with the code yourself. So the kind of back and forth conversation.
Let's use AI to generate some code for this dinosaur.
Okay, thanks.
When I click on you, disappear and then come back. It works. It hides, waits 1 second, and then shows. Let's have it move to a new spot each time. Here we go. Oh yeah. Dinosaur moves to a new spot each time. Now let's make it into a game. I want some points. Give me 10 points each time. Huh. Now it's saying my score is 0. What happens when I click? 10, 20, 30, 40, 50. Not bad.
Okay, so that's just a little example of using AI to directly generate the code. One of the things that we think about in facilitating creative Scratch experiences is this idea that you keep your hands behind your back. I don't know if you've ever tried to teach a kid something, but it can be frustrating when they don't do what you think you expect or want them to do, and there's this temptation to go in and fix it for them. And what we realized after making this was that it's kind of doing that. And so maybe, on the one hand, we should build an AI coding assistant that doesn't actually provide the code for you. And so we're exploring that direction. On the other hand, I'm really inspired by, there's this proliferation of new tools out there like, well, I won't name them, but the ones that build whole software stacks for you from a prompt. So prompt to a working website or web app. You've probably seen this. And that has this incredible engagement power, motivational excitement. The 0 to wow is seconds. And so what if Scratch was like that? We don't know. We're exploring different possibilities. And then the last example I want to show is turning this whole thing upside down. Instead of putting AI into the editing environment to help you code, what if you put AI into the blocks? So you could build your own AI-powered application using Scratch. So that we call the AI blocks, and here's a little demo of what that one looks like.
When I click this block, it asks the AI, who are you? The response appears in this block. I'm an AI language model. Now, what if it thought it was a cat? So we'll use the system prompt to tell it how to behave, and I'll build up a little program to have the Scratch cat say the response. Meow, I'm just a curious cat. We can have it make up silly words like fruital-wink or flibber-jabber. Let's have it speak one of those words aloud.
Flavor-wump.
We can make a custom chatbot like this rhyming lime. Hello, Lime. Hello, it's dinner time. What do you want to eat? A sweet treat would be neat. I made one character I can talk to. Why not make two and have them talk to each other? Okay, what's the problem on this spaceship? We're running out of air. Don't worry, says the dog. I'll just open the window and let some fresh space air in. And the robot says, I'm sorry, but opening the window in space isn't a good idea.
So as you can see, we think that putting that creative power of AI into kids' hands could open up a whole new space of possibilities for AI-powered creative projects. So those are just some directions we're exploring. Like I said, they're all speculative. But our focus, as it has always been, is to build creative tools that help kids transform their sense of who they are. And AI is going to be part of that in some form for what Scratch provides for kids around the world in the future. Thank you.
Thank you, Eric. How many of you want to go online and build out a dragon story right now? Because I'm just going to go and do that. That was amazing. Thank you so much. It's so inspiring to see how exposure to the internet, exposure to tools online for young learners can mean something like that. It can mean two things. It can mean that they're interested because there are the right nudges. I mean, the fact that you can put blocks together and it can make sounds, that's interesting, right? So it's actually able to grip young learners' attention and get them to learn. At the back end, they're acquiring particular psychosocial and cognitive skills. So once again, thank you so much, Corinne and Eric. Please join me in a round of applause for both. Great, now to the next fun part. There's a couple of questions that I have selfishly come up with. No, I'm joking. We actually had a really good conversation and we're crowdsourcing for some of the most trending and topical questions that come up. There will be an opportunity for all of you or some of you, whoever's interested, to join us outside after the session. If you have follow-up questions, we'll definitely stick around and love to hear from you. For now, two of the sort of the most recurring topics that come up, no surprises. Number one, safety. The second one that keeps coming up is equity. So I'd love to invite you both, Eric and Kareem, to share with us in more of a dialogue, more of a discussion around where are you on that journey of safety, particularly thinking about the design and development and use of large language models, LLMs. Where are you in that journey? And that's more at the back end. The front side of the question is, what are some of your perspectives around embedding safety features into some of the tools that are going into the direct hands of learners and educators? Feel free to start, whoever's more comfortable. Go ahead.
It's a big, complex question. The Scratch online community really depends on our ability to create a safe space for kids to communicate. And so we've relied over many years on a team of moderators working around the clock to help keep the user-generated content safe, and on the kids themselves who act as, they self-report content. And if you've ever been involved with content moderation, you know that it's hard to scale. And so we're starting to investigate how AI could play a role. But it's not an easy problem to solve because of the complex nature of our community, the kids of different ages around the world doing wildly different things from each other. And then when it comes to the safety within the tool, of using, say, some kind of LLM-based service within the Scratch editor, that's a hard problem of a new and different kind. Kareem and I were talking recently about the fact that when you put creative tools into kids' hands, it's not just that occasionally you'll see some extreme input result in a funny output. It's that kids by their nature push the boundaries. And so you actually have to design for this idea that kids themselves are their own red teamers. They are pushing the envelope in all sorts of ways. They'll think of everything. And because we are making these tools that empower kids to be coders, we're also empowering kid hackers. And a lot of them really, push our system in all sorts of ways. And that means that when you combine our coding tools with something like an LLM, which is inherently generative, stochastic, unpredictable, you have a very difficult problem. We anticipate finding ways to apply our philosophy of keeping the agency in the hands of children, keeping things safe and creative but still open-ended, in ways that provide adequate guardrails, but we don't know exactly yet how it's going to work, and that's the big challenge ahead of us.
Yeah, I love that point. The red teaming point is so fascinating. These students they're just going to push your systems. They're the ones that will actually test your systems to a level, or our systems, maybe not all your systems, but our systems to the edges. So jailbreaking is something we think a lot about at code.org. As you saw, I showed you a teacher-facing product, and we've been very judicious in our thinking about how to approach student-facing AI tools. Similar to Scratch, we have a community of students who are creating student projects, and content moderation is an important thing that you have to do at the scale that we both operate at. And so AI tools helping there is definitely something that I think will be part of the solution as we move down that path. The one thing I want to call out, we've just also released ourselves a student-facing curriculum. All our curriculum is really teacher-supported, so teachers and students in classroom. And a few of the learnings we had in building out that AI curriculum, this curriculum allows a student to essentially customize an LLM. So if you think about what you've done with all the different, every LLM out there has some way that you can create a GPT, a gem, whatever it is that you steer it, you ground it, you maybe do some RAG, and then you have a little bit of a bespoke kind of vertical LLM. So we're allowing students to do that because what we want to do is teach them about the large language model from a conceptual perspective, and then get them hands-on with it. And in turning that LLM over to them, we were a little bit anxious about that. So a few of our learnings, one was test the daylights out of the system before you put it into your users' hands, and bring them into the testing and ask them to break it. And if you do that, guess what? They will oblige. They will try and break the system. So that was one really important, obvious thing to do. But I think with these technologies, to Eric's point, understanding how to get your users engaged in these non-deterministic systems, I think is important. The second thing that we learned is you actually might have to use multiple models. Like you might use a model to do pre-filtering and then response filtering after the fact, and a different model to actually do the actual processing of the request. And that's something that it was funny. We were like, Model A, Model A, Model A, and then we stopped for a moment and said, what if we used Model B on this end and a different model over here? All of a sudden we had a much better solution. So I would definitely encourage thinking about those sorts of techniques. It'll be like an ensemble of things that come together to essentially produce the outcome you want. And then the last thing that we do, because we have this sort of two-sided experience in the classroom, is anything we showcase show the student, as they enter input, we actually aggregate that and enable the teacher to see that. It gives the teacher, again, the agency of the classroom facilitator versus removing them from the equation, right? They're not just there to teach, they're there to create a safe space. They're there to open minds. They're there to impart knowledge and skills. And so don't forget that part is something that we relearned as part of our process.
Wow, thank you so much. Lots for us to chew on and to remember, as you're saying, we're still at the start of that journey, and we're all testing and experimenting with ways, but it sounds like engaging learners, giving them that dignity, giving them that significance, being part of that, creating the journey with them as users is giving us a lot of evidence for what safety needs to look like. Because in the end, what we're creating is shaped by their behaviors. So engaging them early helps us identify where the guardrails need to go. Last but not least, I definitely want to raise a question around equity and really distinguishing that from equality in the sense that with equality, I often think it's around, you're giving two people the same opportunity, right? With equity, it's understanding where the two people are coming from and tailoring that opportunity accordingly. So there's a big distinction there. And I'd love for all of us to understand, how does equity in terms of inclusion, in terms of disability, in terms of gender, is coming up as you're scaling these fantastic products globally across so many countries, languages, contexts, desires, aspirations.
You wanna lead off? You want me to?
Oh, sure, I'll jump in. The work of equity and accessibility is just an ongoing road. You can always do better with it. Scratch is used by people all over the world, like code.org, and one of the ways people use it is offline, so places that don't have reliable internet access or any internet access, and so they use an offline version of Scratch. And so we try to keep in balance our efforts to remember that a huge part of our audience is not even on the web. So that's one concept, is just access to the tools. It needs to be online and offline. In terms of accessibility to people with, especially with visual disabilities, we're starting some new work next year to try to improve the support for keyboard navigation and screen readers across the whole Scratch ecosystem. So it'll be exciting to actually improve that, but it's a difficult and complex set of problems to solve. And then one other way broadly that we try to improve the equity of our platform across all the different people that use it is to include their voices in the design, as we've been talking about. We have a program called the Scratch Education Collaborative, which is a network of over 100 nonprofits, all of which, and they're spread all around the world, all of which serve underserved communities of youth using Scratch in creative ways. And then we work with them to help them develop their programs in a way that's localized to their context, and also they give feedback to us about how we could solve their problems better. And that's these education nonprofits. And then we also have a new program we're developing to bring the voices of kids in a more formal way. We've always worked with kids and listened to kids, but we have a new advisory board that we're developing with kids around the world to get more formalized feedback, for instance, about our AI work.
Yeah, I just plus one. You know, the complexity of the surface area when you're teaching students at the scale that we do definitely is an interesting challenge. You know, to the points Eric just made, like whether it's offline, a variety of accessibility requirements, languages. It's just so important to have the platform right, and I think you know, we just strive every day to make our platform just a little bit better, right? I think there are a few ways in which AI can help us. Some of our hypotheses, I'll say, these aren't yet, like, I'll say validated, but they're things that we've been experimenting with. You know, if you look at the difference between the learner who's getting the least level of learning to the most level of learning, today in classrooms it looks like this, at least especially in computer science classrooms. And part of that is not only context of the student, but again, to the earlier point, where teachers are at. Are you a teacher who's been teaching computer science for 10 years, or did you just take your 5-day professional learning course this summer and now you're, you know, teaching a year-long high school computer science class? It's a very different outcome in that classroom. And that's not a criticism of the teacher. They're doing amazing work. There's only so much they can do with 5 days of experience teaching Java, as an example of an AP course that, you know, teachers teach. So we see this sort of this delta between them is very wide. We think actually that appropriately applied AI tools can do two things. One, we think that we can actually compress that and we can lift them all together. And a few techniques why I point that out. So differentiation, which we touched on earlier, right? If an AI system can support a teacher in finding the right way to reach that student that might be struggling, we can lift them up a bit, right? That's step one. If a student who may be neurodivergent, maybe has an accessibility challenge, maybe they're just shy, maybe English is a second language and they don't want to raise their hand because they don't want to be seen as a 12-year-old who doesn't know the answer to the question in class, but they can type and have an interaction with a safe AI model about the problem that they're facing, that's another lift up, right? Mm. So this idea of the band of like learning outcomes is too wide. How can AI do this and shift them? That's kind of our thinking about equity. Another area that we focus on when we think about equity, I've touched a number of areas, is girls in the classroom. The percent of girls that are in high school computer science classrooms is 32%. So it's almost 50% at elementary school, drops to about 42 in middle school, and tails off to 32% in high school. It's a huge problem. And by the way, that's not a US problem only. This is a challenge across the globe, right? In fact, in some countries, it's actually even more accentuated than that. So thinking about how do AI solutions or non-AI solutions engage female students to want to take computer science, to learn more about AI, to see how these systems can be used in their real world applications and help them solve the problems and, you know, learn and do more interesting, fun, cool things like Eric showed, right? How do we bring that to our young female students? So that's something that we're thinking a lot about in our curriculum and in how we talk to students and teachers.
Thank you both. It's really interesting to start seeing the model of youth advisory models, or communities, organizations, youth advisory boards really take up. And I'm starting to notice that, and to see Scratch take it up at a global scale, I think it's going to be a great lesson and role model. But we're not stopping there. We're not just bringing in the voices. Kareem, you talked a lot about how you're privileging and prioritizing how learners interact. Are they feeling safe to maybe be able to type something rather than voice it? So we're hearing both voices and we're seeing the interactions. Both are some of the ways in which equity is coming up, because it's not, one size does not fit all. That will never happen. That's not the reality. The beauty of mankind is in a lot in our diversity and coming together through that. But I hope that you have learned as much as I certainly have today around how your organizations are really prioritizing agency, that AI is being leveraged as a tool for good. It's being leveraged as a space for innovation. And I also especially appreciate where you've said that we don't have all the answers yet, but that we're on this journey together. So thank you. Thanks to all of you for listening. There's so many of you. This is incredible. Thank you for being here. And please join me once again in a round of applause for Kareem and Eric. Right.